Hi guys, the other day I got a question about abstract derived types. So I wanted to spend a little bit of time discussing what an abstract derived type is, how you use them, and some reasons that you might want to use them. So let's just start off with some example code. So if we're talking about abstract derived types, the first thing we need is a derived type. So I've declared the simplest possible derived type you could have here, just a derived type with nothing in it. So if we want to make this abstract, all we have to do is add the abstract keyword before the double colons on the type declaration, and there you have it. Now you have an abstract derived type. Okay, but now we need to discuss what does this mean, and then why would you want to do it? So the first thing that this abstract keyword does for us is it actually takes something away. We now are no longer able to declare a variable of this type, and we're also no longer able to construct values of this type. So in practice what that means is I can now no longer say type showable some variable. It tells me some variable is of the abstract type showable. So I can't create a variable of this type. But I still can actually create a variable that can potentially hold a value, if I can spell out cable correctly. Now, what I've said here is now class. What that means is that this variable can hold something of this or a type extended from this type. So we've said that this is abstract, so we now know that we actually won't be able to store something that is of type showable in this variable, but we do know that we can store values of types that are extended from this type in this variable. And so at runtime, when you allocate this variable, it will get allocated with a specific type that must be extended from this type. But there's something else that this actually buys us now. There's something that we can do with abstract types that we can't do with regular types. And that is, I can now define a procedure inside this type and give it the deferred attribute. So in this example, what I'm doing is I'd like to have a type that can be converted to a string. But I'd like to not have to say how any particular type gets converted into a string. And so right now with this syntax, we still have an error here because it's saying that an interface must be specified for the deferred binding, right? So if we're going to say that the objects of this type or types extended from it are going to have this procedure but not provide an implementation, we have to tell it what the interface is. So the way that we do this is we specify a name of some interface. Okay, so where does this interface come from? We define the interface to this procedure in an abstract interface block. And so what we'll do is we'll say pure function. So already I'm now specifying something about the interface to this procedure. It is pure, and it's going to be a function. And the name that I specify here is the interface. So the name of this function is the name of the interface, which is why I've appended it with that underscore I. That's a convention that I like to use. You don't necessarily need to follow that specific convention, but I find that that's helpful to just annotate. This is an interface, not an actual function. But anyway, And so then a normal convention is the past dummy argument will be named self, and I'm only going to have this function take one argument, the past dummy argument, and the result is going to be string. So now I have to specify the types of these. So since it's the past dummy argument, we specify that it has to be class, showable. It's going to be intent in, since this is a pure function. And then I'm going to make the result an allocatable character. However, since this is inside of an interface block, we don't get all of the names in scope. So we have to explicitly import the showable name inside this scope so that we can use that class there. And so what this says is we'll go ahead and jump into, okay, so now that I have an abstract type, if I want to be able to create values that we have to have a type that is not abstract, that extends from this. So in order to extend from this type, we use the extends keyword and get the name of the type we're extending from, and we'll make this a showable integer. Let's do that. Okay, but what this is now telling me is a derived type must be abstract, or I have to give an implementation for these deferred functions. So I can do one of two things. I can either mark this type as still abstract because I haven't provided the implementation for this yet, or I have to provide an implementation for it. So what I'll do is I'll go ahead and say I am going to provide an implementation for toString, and but what will usually happen is you'll give the function that's the actual implementation will have a different name, and so you'll need the renaming syntax here with the arrow. So by convention, what I'll usually do is prefix the name of the function with the specific type I'm giving the implementation for, so I'll call it showable integer toString. Right. And so now I need to provide that actual implementation. So it's going to be a pure function, and what this is going to do, I have to give it the name that I specified up there, so we know what name it is. And what this does is I have to conform to this interface exactly, meaning the names of the arguments must be the same and all of the types must be the same. So this is going to be self. The result value actually isn't quite part of the interface. The type of the result is part of the interface, but you actually don't strictly need to specify result with exactly the same name because the result is not part of the interface. Usually I will because it's already been given a meaningful name, and I'll just go ahead and use that name, but that's a caveat that it's not strictly necessary. But there's also one more caveat. When I'm providing the interface for a deferred procedure, the past dummy argument actually doesn't have exactly the same type. In the interface, I've said class showable, and this is where the reason that if you've ever worked with derived types before and defined type-bound procedures, the past dummy argument always has to be defined with class. The reason that is if you extend from something that's not an abstract type, what happens is the extended class actually gets the implementation for the type-bound procedure from its parent type. So when that procedure gets called, it will actually be called with an object that is of a type that is not the type that that procedure was defined for. It's one that's extended from it. And that's what class does. But when I'm extending from an abstract type, or really if I'm extending from any type, if I want to provide an implementation for my extended type, that pass dummy argument needs to be of class of that type. So that's one subtle distinction where the actual interface isn't exactly the same. So what happens is this now needs to be type showable integer, class showable integer. It still needs to be intent in, and it still has to have the same name. But its class is the class of the extended type. And then the result value still has to have exactly the same type. Okay. And so now I am free to provide whatever implementation I would like for showing an integer, converting this type into a string. In this example, my desire here is to say I'd like to start defining procedures that can take types, any type that conforms to this interface. Any type that knows how to convert itself to a string can be passed to some procedure that I want to write somewhere else. And so at this point, I can define types that extend from that, pass them into procedures that take class showable. That procedure could be in a completely different module, in a completely different package, written by somebody else who has no idea that, but I can create a derived type that extends from it, and that type can be passed into that procedure with that procedure not ever having ever known that that type existed, and that that type didn't have to exist when the procedure was originally written, and things will still work. But I get to provide whatever implementation I want, and it will still work because it conforms to the interface. So I can do something goofy if I want. It's not necessarily a meaningful example, but I could say, let's say that this type is going to contain an integer. I can do something goofy and say repeat, and I think it goes in this order. Yep. So I can just say, well, for this representation of this type, when you convert it to a string, it's just however many exclamation points that was, the integer number of how many exclamation points happened to be for that number that it was holding on to. And this is now valid. I mean, it's runnable. It's not necessarily meaningful. It's probably not an implementation that you would actually use, but it's an example that just kind of demonstrates what we're at here. So next, let's take a look at some real code that makes use of this functionality and provides more concrete motivation about why we might want to use abstract types. And so my first example comes from one of my open source libraries, the Quantities for Fortran library, the goal of which is to provide type-safe ways of representing physical quantities that will have some unit associated with them, i.e. time or mass or speed or what have you, and still be able to do math with them, and in a type-safe way that guarantees that you're doing unit conversions correctly and remembering that these values have units associated with it, et cetera, et cetera. And so I've got a link down in the description to a video I did where I actually discuss the motivation behind why I used this feature and the details of how this particular example is implemented. So I won't go into great detail about how and why this one specifically was implemented, but I'll kind of give you a brief overview of what it was about. So the idea being that I want to be able to convert a number into a value that is a quantity with some units associated. So I need units associated with it. So I need a way for the user of this library to specify the unit that this number has associated with it. So you can convert, say I've got 10. Well, I want to convert that to a time. Well, 10 here is seconds or days or what have you. And so now I have a time value that I can pass around, and I don't have to worry about what the original units were. But so when I define the abstract type that is a unit that is supposed to be the base for a unit of time, a times unit, a time unit, I know for sure that I definitely am going to need a conversion factor. So I can go ahead and put that here into the abstract type. And that forces anybody who extends from this, they already get a conversion factor. And so when they define a value of whatever type they define that extends from this, they'll have to provide a conversion factor. And so now knowing that one will be provided, I can use the conversion factor in the rest of the library. But there is something that I don't know, or I'm not going to have an implementation for it, but I want to be sure that somebody who extends from this will provide an implementation for this. So I need to be able to convert a unit to a string, format that a string that has a number and a unit, and I want to be able to take a string and convert that back into a quantity. And so what I do is I provide the interfaces to each of those three procedures, and now throughout my library, any procedure that is going to require a unit can know that those procedures will be available, even though there's no implementation necessarily provided. I happen to have provided an implementation. I do have a type that extends from the abstract type, and I do provide an implementation for that. But now the users of this library don't necessarily have to use this. And the motivation behind this was I, as the maintainer of this library, don't want to have to support every possible formatting that somebody might want for quantities with units. I had already, if you go and watch the video in the description, you'll see that I had already started down this path of trying to support different formats, and so at that point it becomes clear no, I need to be able to support any format that anybody might want without having to change my library. And that's where the abstract types really become useful, is I can now specify an interface that a type must conform to, certain procedures and the interfaces to those, and then use them without having to know what the underlying implementation is. I can decouple my library's dependency on some behavior from the actual behavior, and somebody else can provide a completely different behavior, and my library doesn't have to change at all. This is called the open-closed principle. And like I said, that video down there in the description will go through the details of how I came up with this design for this example. And so another example use case that I have for this is in the FPM, the Fortran Package Manager. We're starting to implement that in Fortran, and there's a section of the code that's going to deal with parsing the command line and figuring out what it is that the user's trying to do with it. Because basically there's several modes of operation with several commands that FPM is going to need to support. And so the basic idea is that in some ways I would like to decouple the parsing of the command line and figuring out what it is that the user wants to do from the actual doing of whatever it is that they want to do. And so I want to provide a clean break to kind of separate those two functionalities here. And depending on what it is the user wants to do, there are going to be different settings, if you will, that dictate how FPM is going to behave. And different commands are going to have different settings that are valid for them. And so I actually want to have different types because they're going to need to contain different data. And so what I can do is I can provide a single just empty abstract type and say, this is the base type of settings. And then be able to say to one section of the code, this is the section of the code that deals with parsing the command line and getting the relevant settings. And it can return just the settings type. So that if in the future we have different commands that become available, and they have, again, still different data associated with them, I don't have to change that interface. And I don't necessarily have to change the way that behavior is implemented. And so what this allows me to do is now I can pass around these settings without having to know which settings I'm trying to pass around. And so you can see that there are different types that extend from this, but this get command line settings routine returns something of class settings, so that, for example, in the main body of the program, we can say get the command line settings, and now depending on which type, so you get this select type construct, which can now at runtime figure out what's the actual type in this variable, because it can't be a value of type command settings. It has to be one derived from that. So which type is this actually at runtime? And so now I can actually specify that the specific behaviors, the sections of the code that deal with the different commands, actually take in specifically the type associated with it that contains those settings. And so what that forces me to do is I can have a single way of getting the command line settings, but I am now forced to figure out specifically which command and which type do I have, so that I can pass it to the appropriate sections, to the sections of the code that do the appropriate thing based on that command. And so this gives me a little bit of a type-safe way of saying, I have a general action that I'd like to perform that's going to return me something, and then forces me to deal with it at the type level of figuring out at runtime what the types are, of saying, okay, now that I've gotten this result, what am I supposed to do with it? And it forces you to do that via the type system. So it won't compile if you don't do this correctly. So it kind of removes a class of error that might be possible where I could pass, if I hadn't done this pattern, I could inadvertently pass the settings for the build command to the install command, and that doesn't make any sense, but since they're now different types, I can actually at compile time prevent that kind of bug from happening. In other languages, the pattern I'm using here would generally be called a discriminated union, or some languages still call them enum types, but they have this additional functionality of where like I can basically say, here's the type that I'm concerned about, but here's different kinds of values that will be of the same type. And so this is a little bit of a taking a pattern from a different language and trying to kind of fit it into Fortran's capabilities. but there are some instances where this does turn out to work out fairly well. You will want to be careful about places where you use this. Don't try and apply this pattern everywhere, just as a note of caution, because if you find yourself repeating this select type construct in multiple places, you may have actually applied this pattern in a place where it's not applicable. Because if this gets applied in lots of, if this construct ends up appearing in lots of places, if you add one, you have to go find all of the places where it's been defined and add those cases there. And so in this instance, this is at the very high level of controlling the flow of the program. So this is probably the only place where this select type construct will appear. So it's safe in this instance, but it's not a pattern that's necessarily applicable. But the abstract type and extending from it is a way to kind of express that pattern. So that's the basics of abstract derived types, how you define them, how they're used, and some use cases for where you might want to use these in your own code. I hope that was an informative and clear enough description of all of that stuff, and that you found some use out of it. If you did, please go ahead and hit that subscribe button, hit the bell button so you get notifications when I release new videos, and let me know down in the comments if you have any additional questions or have any ideas for additional topics that you think I might want to cover.